The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Alrighty, so today we're going to review for the first test. The first test is tomorrow, and it needs to be finished no later than 11:59 p.m. tomorrow night. A reminder, there will be no regular class meeting at 10:30 tomorrow morning on Zoom. So if you show up there, you'll probably see a sign from me that says, no class, just take your test. Anyway, I had one request through email. So let's take a look at that problem. This is from the chapter review. Number 12. It says, find two arithmetic means between 8 and 28. All right, since we're talking about arithmetic means, we're going to be using the formula a sub n equals a sub 1 plus the quantity n minus 1 times d, where d is the common difference, and n is the subscript of the term. It says two arithmetic means between 8 and 28. So a sub 1 is 8. Then we have a sub 2 and a sub 3, which we need to find. And then a sub 4 is 28. Any questions about how I established that that was a sub 1 and a sub 4? All right. So a sub 4 would be a sub 1, which is 8, plus n minus 1, which is 4 minus 1, times d, the common difference. A sub 4 is 8 plus 4 minus 1 is 3, so 3d. But we also know that a sub 4 equals 28. So from that, we get 8 plus 3d equals 28. 8 plus 3d equals 28. Solving for d, we'll subtract 8 from both sides of the equation. 3d equals 20. Divide by 3, and d equals 20/3. Okay, so 20/3 is the common difference. So a sub 2 is going to be 8 plus 20/3. So 8 plus 20/3. To add two numbers where at least one of them is a fraction, we need a common denominator. 8 is the same thing as 8 over 1. The common denominator is 3. So I need something over 3 plus 20 over 3. I'm going to take the 8 over 1 and multiply it by 3 over 3, which gives me 24/3. So 8 changes into 24/3. 24/3 plus 20/3 is 44/3. So a sub 2 is 44/3. Now, we're going to take a sub 2, 44/3, plus d, 20/3, to get a sub 3. So we've got 44/3 plus 20/3, which is 64/3. Okay. Then just to make sure everything's working correctly, 64/3 plus 20/3, 64/3 plus 20/3 would be 84/3. But 84/3 is what? Let's see, that would be 28. So it checks. So the two arithmetic means are 44/3 and 64/3. Any questions about that? All righty. So let's go through the different sections that we're on, that are going to be on this test. And let's see here. let's take a look at some inequalities, linear inequalities. Okay, so section 3.7, it was about graphing linear inequalities. So things to remember: solving an inequality for a variable is like solving an inequality for an equation. You can add the same quantity to both sides of an equation, both sides of an inequality as well. You can subtract the same quantity from both sides. You can multiply or divide both sides by the same non-zero number. But if you multiply or divide both sides of an inequality by a negative number, you change the direction of the inequality symbol. Okay, now as far as graphing goes, we find 2 points that are on the line formed by the equation. Then we graph that line. If the inequality statement doesn't include an equal sign, the line's going to be dashed. If it does include it, it's going to be solid. Then we pick a test point to see which side of the line it's on, yada, yada, yada. Let's do one. Okay. All right. So let's see. Let's say we've got this. 3x minus 3y greater than or equal to -10. Okay. So I'm going to consider the equation 3x minus 3y equals -10. Okay. I'm going to make a table, find some ordered pairs. Let's see. I think I'll find the intercepts and see if that works okay for us. If y is 0, 3x minus 3 times 0 equals -10. 3x equals -10. Divide by 3, x equals -10 thirds. Okay. If x is 0, 3 times 0 minus 3y equals -10. So -3y equals -10. Divide by -3y equals +10 thirds. So let's go to the WebAssign screen. And remember that we want to use this line, not the ray or the line segment. So I click on that till it turns solid blue. One of my points was -10 thirds, 0. -10 thirds would be -3 1/3. So right about there, 0. But recall that the WebAssign draws it to the nearest integer value. And then 0, 10 thirds, which would be 0, 3 1/3 roughly. Okay, so how am I going to correct my ordered pairs? I go over here and I click on the line. My first point needs to be -10 thirds, 0. And my second point needs to be 0, +10 thirds. Okay, now let's go back to our original problem. Notice that the original one does include the equals to. So that means our dotted or our line is going to be solid, just as it is. Now, recall if I need to change it to a dashed line, I can do that, but in fact, it needs to be solid. All right. So now I need to pick a test point. Is it above or below the line? Below, okay. So let's pick 0, 0 as a test point, since that's not on the line. Okay. And if we take 0, 0 and plug it in here, we get 3 times 0 minus 3 times 0 greater than or equal to -10. 0 minus 0 greater than or equal to -10. 0 greater than or equal to -10. That's true. So 0, 0 is correct. So back here in WebAssign, I'm going to fill in, oops, that side of the graph. Okay, let's see here. Yeah, the graph that we're actually doing is not the y less than or equal to 3x. So I'm going to cover that up. So here is the correct solution. Do you have any questions about this particular problem? Anybody? All right. Do you want another example from section 3.7 before we move on? If you do,
Yes, please.
yes? Okay.
Can we do one of the ones, or unless it's not on the test, but one of the ones that require you to do the shading of an overlap?
Well, that's 4.5.
Okay.
That's coming up next. But
Okay.
3.7 is really just kind of an introduction to 4.5, where you're just dealing with one inequality statement. But so,
Okay.
again, anybody want more examples of this situation?
Yes, please.
Yes,
Okay.
please.
Do you have anything in particular you want to deal with, or just do another one?
Any example is good.
Okay, all righty. Let's see, we'll clear that out and we'll go back here. And let's.
Or actually, would you be able to work on one that has like a fraction or?
Sure. Absolutely. Do you have a specific one in mind?
Not anyone in particular.
Okay, but one that has a fraction in it. Okay, let's see here. Just want to see if there was one that had two fractions, but here's one that has a fraction in it. Okay, it says y is greater than -2/3 x plus 2. Would that one be okay?
Yeah, that sounds good.
All right, so we're going to consider the equation y equals -2/3 x plus 2. We're going to find two ordered pairs. Let's see. Since this has a fraction and it's the coefficient of x and the denominator is a 3, if I choose x values that are multiples of 3, I'll get nice y values. So I'm going to use 0 and 3. And let's see how that turns out. If x is 0, I get y equals -2/3 times 0 plus 2, which is 0 plus 2 or just 2. Okay. If x is 3, y equals -2/3 times 3 plus 2. The 3's reduce down and we get -2 plus 2, which is 0. So we've got two ordered pairs, 0, 2, and 3, 0. Are we okay with that? Any questions there? All right.
Nope.
So now let's go back and let's plot those 2 points. So again, we turn this blue. We've got 0, 2, and 3, 0. Okay. Now let's go back and take a look. And we see that our original inequality didn't include an equal sign. Therefore, our graph needs to be dashed. Okay? Now, we need to pick a test point. Let's go with 0, 0 since it's not on the line and it's a good point to use. So let's take 0, 0 and plug it in here. We get 0 greater than or equal to -2/3 times 0 plus 2, 0 greater than 0 plus 2, 0 greater than 2. That is false. So 0, 0 is not a good test point. So going back here, since 0, 0 failed, that means we're going to fill on the other side of the line. So the solution is everything above, but not including the dashed line. Any questions on that example? All right. Do you want another one of these, or shall we jump to 4.5 where we're doing 2 of them on the same graph?
We can go to 4.5.
All righty. Now, yesterday I did this with some students. Let's see if I can be successful with this and not screw it up completely. Here we go. Oh, that didn't do it. That didn't do it. Okay. Let's see here. There we go. There we go. Give me a minute here to get my act together. Now, what I'm doing is making it so that I don't have to go back and forth between the two screens. So we'll see. That's not what I wanted. Maybe we'll make it a little bit smaller. Okay. And we'll make this a little bit smaller. Okay. Now, let's see here. That right there. And see here. Yeah, that's working. Okay. Sorry for all the work there, but I think you'll find this easier to follow. So let's take a system of two linear inequalities. Okay, we've got 2x plus y greater than, oh, can you hang on? I need to share it. Sorry. So now can you see the whiteboard that I use and WebAssign?
Yes.
Okay, that's the plan. All right. 2x plus y greater than or equal to 3. And the other one is x minus 2y less than or equal to -1. Okay, so we're going to go back and solve the black inequality first. So I'm going to consider the equation, which is 2x plus y equals 3. Okay. I'm going to find two-ordered pair solutions, and I'll go ahead and use the x and y intercepts if that works out okay. So find x when y is 0. 2x plus 0 equals 3. 2x equals 3. Divide both sides by 2. X equals 3/2. We okay with that? All right. Find y if x is 0. 2 times 0 plus y equals 3. Y equals 3. So now I've got two ordered pairs. So I'll come over here and graph. Let's see, 3/2 is 1.5. So 1.5, 0, and 0, 3. But again, 1.5, 0 didn't show up where I wanted it to. So I'm going to go, remember, I can't use a mixed number here. If I put 1.5, it's going to think I mean 11/2. So I've got to go 3/2. Okay. So there's my 2 points, and it's a solid line because over here, notice that the original does include equals to. Okay. So now we're going to pick a test point. Let's go with 0, 0. So back over here. Oops. We use a test point 0. I keep accidentally moving the page down. 0, 0. That's going to go in here. So we've got 2 times 0 plus 0 greater than or equal to 3. 0 plus 0 greater than or equal to 3. 0 greater than or equal to 3. That's false. So because that's false, 0, 0 is not a good test point. In fact, it's going to be over there. Okay. And back here, I'm going to write it's above. Okay. Any questions on that? So now we're going to go back and deal with the red inequality. So we're going to take the inequality and write the related equation. We'll find two ordered pairs. Again, I'll use the intercepts. If y is 0, x minus 2 times 0 equals -1, x minus 0 equals -1, x equals -1. If x is 0, 0 minus 2y equals -1, -2y equals -1. Divide both sides by -2, y equals +1/2. Since -1 divided by -2 is positive. Okay. So now I'm going to come back here and graph the second line, -1, 0, and 0, 1/2. Again, it moves to the nearest integer, or at least to a close integer. So I'm going to go back. I've got -1, 0, and 0, 1/2. All right. Now, my second inequality also includes equals to. So both of these lines over here should be solid. Let's pick a test point. 0, 0 also would work. 0, 0. We're going to plug that in here. So that will give us 0 minus 2 times 0 less than or equal to -1. 0 less than or equal to -1. That is also false. Oops. So 0, 0 is not a good test point for the second line, which is this one here. So that means it's going to be above. Okay. So going back over here, in both cases, it's above. So for this line, the fill is above, which is here and here. Okay. For this line, the fill is above, which is here and here. So where do they overlap? On this one up here. So that is what our solution should look like. Now, something we can do once we've got our final answer, let's just make sure, let's pick a point that's within what appears to be the final answer and verify that it's a solution to both the black and the red inequalities. I really wish I could put different colors over here, but I don't think I can. How about 2, 3, right there, 2, 3. Let's try that point. And let's see, let's go with green. So we're going to use the point 2, 3. We're going to make sure that it works in this inequality and then in this inequality. So let's go with the first one, 2x plus y greater than or equal to 3, where x is 2 and y is 3. So we've got 2x plus y greater than or equal to 3, 4 plus 3 greater than or equal to 3, 7 greater than or equal to 3. So 2, 3 checks in the black inequality. Now let's take 2, 3 and check it in the red inequality. So x minus 2y less than or equal to -1, x minus 2y less than or equal to -1, 2 minus 6, which is -4 less than or equal to -1. That is true. So our region checks out for both inequalities. Any questions on this? So I have a question for you. When I was first teaching this, this quarter last week, I didn't use this screen with them both there. Do you find this easier to follow than going back and forth between the two screens?
Yeah, I do.
Okay.
Yes.
Yeah.
I thought so. Yeah, I just finally got around to figuring out how to put this whiteboard on the screen there, and I'm still working on it. But okay, so this is 4.5. Do you want another example of this, or shall we go on to chapter 14?
Maybe another example.
Okay, we shall do that. So we'll clear this and we'll go up there. And let's see. Okay, here's one. Let's see, I need to go back to black here. And so 3x plus 2y minus 12 greater than or equal to 0. Okay. And then our red inequality is x less than -2 plus y. Okay. And back to the black here. So we're going to take the first inequality and we're going to look at its related equation, which is 3x plus 2y minus 12 equals 0. Okay. And let's see here. I'm going to go ahead and use the x and y intercepts. So if y is 0, we get 3x plus 2 times 0 minus 12 equals 0. 3x minus 12 equals 0. Add 12 to both sides. 3x equals 12. Divide by 3x equals 4. Any questions there? All right. Second ordered pair. Let x equal 0. 3 times 0 plus 2y minus 12 equals 0. 2y minus 12 equals 0. Add 12 to both sides. 2y equals 12. Divide by 2, y equals 6. So over here, we've got 4, 0, and 0, 6. And we see that it includes equals to, so it would be a solid line. All right, let's pick a test point. Let's go ahead with 0, 0 again. We're going to check that in here. So I've got, let's see, 3 times 0 plus 2 times 0 minus 12 greater than or equal to 0. So -12 greater than or equal to 0, that's false. So 0, 0 isn't included, which means we're going to fill above it. So I'm going to say above the line. Okay. Now let's go back over to the red inequality. And we're going to look at the related equation. And again, I'm going to find ordered pairs. If y is 0, x equals -2 plus 0, x equals -2. If x is 0, 0 equals -2 plus y. Add 2 to both sides. 2 equals y. Y equals 2. So I'm going to plot, let's see here, -2, 0, and 0, 2. Now, this line, it does not include equals 2, so it's going to be dashed. All right, see that? Let's try 0, 0 as a test point again. So I don't know what I'm doing. Somehow I'm moving the page, but hopefully I'll figure it out eventually. We'll put that in here. So we get 0 less than -2 plus 0, 0 less than -2. That's false. So 0, 0 isn't a good one for the dashed line either, so it would be up here. Okay, and again, above. So for line 2, the dashed line, the red inequality, we would graph above. For line 1, the black inequality, we would graph above. So the intersection would be this region here where they overlap. Okay, and again, let's pick a value there to check. Let's go with 2, how about 2, 7? 2, 7 would be right there. Okay, so we'll pick green, and we've got 2, 7. So I'm going to test it here. 2, 7. Let's see, that would be 3 times 2 plus 2 times 7 minus 12 greater than or equal to 0. 6 plus 14 minus 12 greater than or equal to 0. 20 minus 12 would be 8 greater than or equal to 0. That checks. Okay, let's take this and put it in the red inequality. Let's see, x2 less than negative 2 plus 7, 2 less than 5. That checks as well. So the answer is correct. All right, are we good to go on to the next section?
Yep.
All righty, so now we're going to go to section 14.1, and I'm going to get rid of that, and let's see if I can put that back over here. We'll see what happens. Okay, now, interesting. I'm trying to figure out. Let's see what happens. Here we go. Okay, now we're back to the normal screen, more or less, except you can't see it. So, all right, can you see the whiteboard again?
Yep.
Okay, thank you. So section 14.1 was factorials. Recall the symbol for factorial operation is an exclamation mark. So 4 factorials, like 4 times 3 times 2 times 1. How about this section? Is there anything in particular you'd like me to go through here? Do you want me to do any examples?
Yeah, nothing in particular.
Nothing in particular? Okay.
I have one. Can you do an example of one of the ones, like with the fraction, given an example here? Let me see. Like last night on the homework, there was one that was the AN is equal to, I think it was like -1/3.
Okay. Oh, okay, okay. So, but it's not, so you're actually jumping ahead. You're in 14.2.
Okay, I'm sorry.
That's okay. We'll get there. When we get there, you bring that up. But
Okay.
14.1 was just about factorials. Here, let's say we've got something like this. 6 factorial times 7 factorial all over 8 minus 3 factorial, and then times 7 minus 4 factorial. Okay, so first thing I would do is I would simplify inside the parentheses. 8 minus 3 is 5, 7 minus 4 is 3. So I get 5 factorial times 3 factorial in the denominator. Then I would go ahead and try and reduce out as much as I could. I'm going to take these two and deal with them together, and these two and deal with them together. So 6 factorial, I would write, actually, I'm going to bring it down here. 6 factorial would be 6 times 5 times 4 times 3 factorial. and I'm going to have the 3 factorial in the denominator. So I expanded that enough to get to there. 7 factorial, I'm going to write as 7 times 6 times 5 factorial. And then I've got 5 factorial in the denominator. So basically, I expanded the numerator to where I came up with the factorials that are in the denominator. What that allows me to do is I can come in now and reduce that down to 1 over 1 and reduce that down to 1 over 1. Okay? Now, the denominator is basically just 1. So in the numerator, I've got 6 times 5 times 4 times 7 times 6, which is 5,040. All over 1, which is still 5,040. You okay with that?
Yes.
Right. I'm going to do one more here. Let's say I want to know 17 factorial. So what I'm going to do now is I'm going to go to the internet. Now, this is if I don't have a factorial button on my calculator. If you do, then just use that. But I'm just doing this to remind you, if you put in scientific calculator, this comes up. There's the factorial button. So let's see, it would be 17 factorial equals. And so what do I get there? I get 3.5568743. And then it says E plus 14. So let me remind you what that means. So back here. So this is basically 3.5568743 times 10 to the 14th power. Okay. Any questions about that? All right, let's go on to section 14.2, which was arithmetic sequences. And the formula was a sub n equals a sub 1 plus the quantity n minus 1 times d. All right, one of you had a question, I think, that concerned this. I don't remember who it was or what the question was, but I said, wait till we get to 14.2. Anybody?
It was I think it was an equals the -1/3.
That?
I'm pretty positive that that's what it was.
And that was it?
Let me see if it's on the, can I still pull up the homework from last night?
I don't know.
Like right now.
But if you can't, I can. So let's see. The race is on.
My assignments. Oh, past assignments.
Okay. Okay, so which section is this from?
It's from 14.2.
14.2.
Oh, yeah, and it is. It's or an equals -1 with
What number?
Number 7.
Okay, okay.
With an exponent of n.
I knew there was something missing. It's this.
The exponent.
Right. Okay. Now, I waited to see if anybody asked about these, and they didn't the other day. If they don't give you a formula and they say it's an arithmetic sequence, you're going to use this formula. Or if they say it's a geometric sequence, you'll use that other formula. But some of the problems just give you a formula specific to that particular problem. And that's what this is. Okay. So they give you this formula, and then it says, write the first 4 terms. Okay. So a sub 1, a sub 2, a sub 3, and a sub 4. Okay. So a sub n is -1, the quantity, to the nth power, over 3 to the nth power. So a sub 1 would be -1 to the 1 power over 3 to the 1 power, which is -1/3. We okay with that?
Yes.
A sub 2 would be -1 to the 2 power over 3 to the 2 power. -1 times -1 is +1. 3 squared is 9. So 1/9. Okay. A sub 3 is -1, the quantity cubed, over 3, the quantity cubed. Negative times negative times negative is -1 over 27. And a sub 4 is -1 to the 4th power over 3 to the 4th power. Negative times negative times negative times negative is positive. So +1 over 81. So that's based on this formula that they gave you specific to that single problem. Okay. We all right with that, Ashley?
Yes.
Okay. Anything else specific from section 14.2 that you'd like to look at this point?
Yes, can we do another one? I have an equals 2n minus 7. Find the first 4 terms.
And that's the whole thing? A sub n equals equals 2n minus 7?
Yes.
Okay, find the first 4 terms. Whoops, the first 4, not just the 4th one. Okay, so a sub 1, a sub 2, a sub 3, and a sub 4. Well, a sub 1 would be 2 times 1 minus 7, which is 2 minus 7, which is -5. So all I'm doing is putting the subscript that's here right there. Okay. A sub 2 would be 2 times 2 minus 7, which is 4 minus 7, or -3. A sub 3 would be 2 times 3 minus 7, which is 6 minus 7, or -1. A sub 4 would be 2 times 4 minus 7, which is 8 minus 7, or +1. So here are your 4 first term, or the first 4 terms rather. We okay with that?
Yes, thank you.
All righty. Anyone else, or you again, another specific problem you'd like to look at from 14.2? Okay. Do you want me to do some other examples from 14.2? All right, well then we'll go on to 14.3, which was geometric sequences. And the general formula for that was a sub n is a sub 1 times r to the n minus 1 power. Any specific questions here?
I have another one. It
Okay.
says, find the 6th term of the geometrical sequence with the first term is 1/25 and a common ratio of 5.
Okay, the first term was 126.
1 over 25, a fraction.
Oh, okay. Sorry, hang on. Okay. Read the whole thing to me again, would you?
Find the 6th term of a geometric sequence with the first term of 1/25 and a common ratio of 5.
Okay. So a sub 1 is 1 over 125, or 1/125. The common ratio is 5, and we're to find a sub 6. So since we know the first term and we know the common ratio, we can just plug that in to the formula. A sub 6 equals a sub 1 times r to the n minus 1 power. So I've got 1 over 125 times 5 to the 5th power. Okay. Now, if I take 5 to the 5th power, I get 3125. and I've got 125 in the denominator, okay? 125 is 5 cubed, so these things should reduce nicely. We've got 5 to the 5th over 5 cubed. 3125 divided by 125 comes out to exactly 25. So there's your 6th term. All right with that, Sonia?
Yes, thank you.
Mm-hmm. Something else from 14.3. We've got about 4 minutes left. Anybody? Anything?
I have
I
more
have a
if nobody
question.
else has any.
Suddenly everybody has some. What's
Okay.
that? Go
I
ahead.
have a, okay. So I have a question for number 7.
Can you read it?
Yes. It says first term 56 common ratio 1/2.
And
It's asking to find the A1 and then A2, A3, A4, and A5.
so find the first 5 terms,
Yes.
and they give us the first term
Yes.
and the
And
common
then-
ratio.
Mhm. And then also it's asking to find the 9th term.
The 9th term. Okay.
Yeah.
All right. So let's move this over here. So we know the first term is 56. We want to find the first 5 terms and the 9th term, and the common ratio is 1/2. So using the formula a sub n equals a sub 1 times r to the n minus 1 power. Okay. So basically, we take the first term times the common ratio to get the second term. What's 56 times 1/2? That would be 28. 28 times 1/2 would be 14. 14 times 1/2 would be 7. 7 times 1/2 would be 7/2. Now, remember, don't use 3.5. Don't use a mixed number. You could use a decimal if it's exact, but 7/2. Okay. Are we all right with those?
Yes.
Okay. So now a sub 9 is a sub 1 times 1/2 to the 9 minus 1 power, which is 56 times 1/2 to the 8th power. Okay. So 56, 1/2 to the 8th power. And a sub 9 is, oh, we've got all we need. We don't have to set up an equation. I was making it harder than it has to be. So let's go back here. And let's do the math. So that's 56 times 1 to the 8th power over 2 to the 8th power. Why am I doing that? So I don't get a decimal answer. Okay. Now, 1 to the 8th power is 1. 2 to the 8th power, 2 to the 8th power is 256. Okay. Now, I can reduce that. 56 is 7 times 8. And 8 is 2 cubed. So 2 to the 8th power would 8 would be a factor of that. So basically I'm going to divide, well, let's see, first of all, I got what, 56 over 256. I'm going to divide the top and the bottom both by 8. So I get 7 on top, 256 divided by 8. You got to turn the calculator on first. 256 divided by 8 is 32. You okay with that?
Yes.
All righty. It is time. So I'm going to go ahead and stop the recording.